there'll be one question where you have to find the derivative using the limit idea. So that'll be number 1. Use the formula for the derivative, which is the limit of f of x plus h minus f of x over h. Okay, so we're going to have to use this. So the function they're giving us for review is this guy. I'm going to use f just because that's what we used up here. X plus 5, x over x plus 5. If you were to do the derivative rule, this would be a quotient rule, but they want us to use this formula. Okay. So let's go ahead and write down what everything is. F of x plus h would simply be x plus h over x plus h plus 5, right? You plug in x plus h wherever you have an x, get here. Subtract them and divide by h. So the limit of f of x plus h minus f of x over h. That would be the limit as h goes to 0 of x plus h over x plus h plus 5 minus x over x plus 5 over h. So simplify everything and then cancel the h and then take your limit. Whatever's left over will be your derivative. Right, that's what this does. Right now it looks pretty annoying. X plus h plus 5 is its own denominator, so is x plus 5. So these are prime. So you're going to have to get a common denominator. They're just not pretty. So multiply x plus 5 on this one. On the first fraction, and then multiply this guy by x plus h plus 5 on top and bottom. So we get the same denominator. There we go. So now we can combine them into one fraction. So we will get a bunch of garbage. Let's see here. Remember, there's still, it's all over h still. Okay, I'm going to write it this way just so we can save space. We're going to get, we can multiply this out on top, we're going to get x squared plus 5x plus hx plus 5h minus x squared times h minus xh times that minus 5h. Okay. So notice that these will cancel. I missed a, well, this should be 5x, not h. So this will cancel with that guy. This will cancel with that one. So this will leave us with the limit as h goes to 0 of 5h over x plus h plus, oops, fix that, plus 5 times x plus 5 times h. I'm just go ahead and put that over here. Notice that these will cancel. So now just take your limit and you'll be done. So right here, we'll take the limit. Once you take the limit, you no longer write the limit notation. So we're going to have 5 over x plus 0 plus 5, x plus 5, which gets us to 5 over, it's going to go ahead and put it over here. 5 over x plus 5 squared. So if you would have done the quotient rule, you would have gone straight to here. But you'll have one question where you have to do the limit rule. Is there any questions on any of these steps here? Is the algebra okay? Do you see that we're just using this formula? It's just that the algebra was kind of annoying because we had a fraction, a rational expression here. All right, so that's the first one. You guys cool on number 1? All right. So that was number 1. Number 2, find the slope of the curve at the indicated point. Let's do number 3 because this is the same type of question but has more, it's asking for more things. So this is harder. 2, 3. Okay. You guys cool on this page? All right, well, let me know. Can you need me to slow down? Find the equation for the tangent line. On the curve at the given point. So y equals x squared plus 9x and crap, that's the other one. X squared plus 3. And they gave us the point 4, 19. So basically, what we're going to need is this equation. So this is not given to you. Y minus y1 equal to m times x minus x1. It's just that the m needs to be found using the derivative. Okay. So this is x1, y1. The derivative will equal 2x. So the tangent slope is equal to the derivative at the x value, which will be 2 times 4, which is 8. This is the m tangent that's going to go there. Okay. So y minus y1, which is 19, is equal to 8 times x minus 4. So that'll be y equal to 8x minus 32, distribute the 8 plus the 19. That will be Negative 32 plus 19. 13. Yeah. So this is the equation of the tangent line. Number 3. Number 2, all they asked for was a slope. So you would just do this step right here. Any questions on number 3? That's the next one. So 2, 3, and 4 are very similar. So let's move on to something else. Number 5 says, find the points where the graph has horizontal tangents. So that only happens when the derivative is equal to 0. So set the derivative to 0 and solve for x, and you'll find the value they're asking for. Okay. Let's number 5. Find the points where the graph of the function have horizontal tangents. Okay, so what you got to do is take a derivative. So f prime will be 3x squared minus 21, right? Just doing the power rule. So step 1 is right here. Step 2 is set this guy to 0 and solve for x. So move that 21 over. Divide by 3. Square root both sides. So we have horizontal tangents at square root 7 and negative square root 7. But at one of the points, right? So we have to plug this guy in here to find the y value. So step 3, plug in this guy to the original. That'll be square root 7, 49. So usually you write the constant first. That looks weird. 7 times 7 would be 7 square root 7. There we go. Minus 21 root 7, which will be negative 14 root 7. Okay. Now do the other one. Negative root 7, that'll be negative root 7 cubed minus 21 minus 21 first, minus 21 times negative root 7. This would be negative 7 root 7 plus 21 root 7, which will be 14 root 7. There we go. So the answer will be root 7, comma, negative 14 root 7, and negative root 7, comma, 14 root 7. So these are the locations where you have horizontal tangents. So you find the derivative, set it to 0, solve for x. And you get these. Any questions on number 5? Does that make sense? Good. Gosh. Wish you told me sooner. Yeah, missed that. Okay. Yeah, well, let's go over it one more time now that it's written down here. Sorry about that. So to find the points where the graph of the function have horizontal tangents, right? You take the function, find the derivative, set it to 0. Solve for x, and you get these two x's in this example, root 7 and negative root 7. But the answer points, which means you have to plug it in to the original function to find the point. So this is the y value, so you get the x and y. I found the x earlier, so plug in that one and you find this one. So right here, just plug in the numbers, find the points. X values are found with the derivative set to 0. That makes sense? Sorry about that. Let's move on to a different one. Let's switch this to. Okay. Let's move on to these types of derivatives. 7, 8 are products, 9, 10 are quotients. So let's do one of each and we'll move on. You guys have any questions on number 5? Okay. Let's do 8 because it looks harder. Find the derivative. They use z, but I'm just going to use f of x, I guess. It's going to be 8x squared e to the x. Okay. So the derivative, well, you know what, let's use y because on the formulas we had f and g. So we'll do that. So the y, f of x will be the first piece, g of x will be the e function. The derivative will be itself. Derivative of f prime will be 16x, right? Okay, so the derivative of the product will be f prime g plus G prime F. Right? So that'll be, parentheses aren't necessary, but when I use them, you can. This will be 16x e to the x plus e to the x 16x. So this will be the same thing, it looks like. No, this should be 8x squared. Okay. You can factor if you want. They both have 8x in common. They also have an e to the x in common. You can factor those three things, leaving 2 plus x. You don't have to factor that, but there it is. Okay, let's do number 9. So y of x is equal to x squared plus 5 over x squared plus 6. So the top is f. The derivative would be 2x. The bottom is x squared plus 6. Okay. Double check. I think it's f prime g minus g prime f. Double check, 'cause I don't trust this right now. Yeah. So the derivative will equal f prime g minus g prime f over g squared. So that will be 2x times x squared plus 6 minus 2x times x squared plus 5. Squaring the g on the bottom. That'll be 2x cubed plus 12x minus 2x cubed minus 10x over this garbage. I don't know if it'll simplify much further, but let's just check, I guess. It looks like these terms will cancel. That's cool. 12x minus 10x is 2x. I think this is as good as it's going to get. Any questions on number 9? Okay. Number 11, let me show you. So 10 is just another quotient. You could divide them and then do it, but whatever. So to you on this guy. 11 wants you to do two derivatives of the same thing. So you do it one time and you do a product and then you do it again. Okay, have any questions on 11? If not, I'm going to skip to 12. Does this seem doable? Okay, then I'll let you figure that out. Let's do 12 then. Number 12. So they use Q and R. I'm going to use y of x and y and x. Okay. So remember, this is a chain rule question. We said that if you have a function inside of a function and you take the derivative, right, that's equal to derivative of the outside times the derivative of the inside. Okay. So the derivative of this guy, well, first we got to rewrite it. Rewrite this as a power. So the derivative will be derivative of the outside. Don't mess with the inside. Subtract 1, then times the derivative of the inside. So this becomes 1/2 times 17x minus x to the 5th, negative half, times 17 minus 5x to the 4th. At this point, you just make it look pretty because it's the calculus step is done. So this stays on top. This half is technically down here. This is the square root. So you could leave it this way. And you bring down the negative power at the bottom, change it back to into a radical. Does that make sense? Let's skip the minor step here. Okay. That was 12. 13 is a product rule that has chain rules. So let's do 13. Just because it looks nasty. Honestly, I think we should probably do another sketch. Find the derivative of y of x is equal to x plus 1 squared times x squared plus 1 to the negative 3. Right, so I have a product And this product is going to require a quotient. So right here, the derivative of f is you take the derivative of the outside times the derivative of the inside, which is a 1. So it doesn't really do anything. So you can just leave it that way. Derivative of this guy would be -3 minus 1 times the derivative of the inside, which would give us -3 x squared plus 1 to the -4th times 2x. So let's just plug it in. All right. Derivative of y. Let me make some space. It's going to be derivative of the first part times the second part plus the derivative this part. You should put it down here. I'm going to rewrite it down here. Same thing. Okay. Just disregard this line right here. I don't wish that. Okay, so this derivative we did over here. So that'll be 2x plus 1 times x squared plus 1 -3 plus this derivative, that's g prime, so that's right here. -3 times 2x, that'll be a -6x times x squared plus 1 to the -4 times x squared. Wait, wrote it twice. This should be x plus 1 right here. I gotta cut it early. That would be x plus 1 squared. There we go. That's f. Because this derivative would be f prime g plus g prime f, right? There's f. Okay, at this point, just do algebra and you'll be done. The calculus step is over. Let's see, what can we do to make it prettier? This is a negative exponent, so that can be x plus 1 over x squared plus 1 cubed minus 6x x plus 1 squared over x squared plus 1 to the fourth. We combine the fractions technically. I don't want to though. But they're almost the same. This one's just missing one more. So multiply by x squared plus 1 on top and bottom to make this a fourth. And then just add them together. Okay, so this will be 2 x plus 1, x squared plus 1 minus 6x x plus 1 squared over x squared plus 1 to the fourth. It's a little prettier. I see an x plus 1 in common. We pull that out and get 2. So we could factor 2 x plus 1 and get x squared plus 1 minus, no, yeah, that's right. Minus 3x which would then combine, I guess you could open that parentheses, but that's pretty much it. Doesn't get much prettier. Anyway, any question on the derivative? I mean, all this was just algebra. Derivative stopped right here. Everything after that is algebra. Okay. All right, let's see what's left here. So we did quotient, product, chain, and then complicated chain, which is this one. Have the implicit. Let's do the implicit derivative. So to do an implicit, they first defined define dy dx. So this is the hint they're telling you to use ddx on both sides. So every single term with respect to x. So that'll be 3x squared plus 6x. So the x's are done the same way you've always done them. But when you do a derivative of a y with respect to x, you have to tack on the dy dx. Okay. That makes sense? Okay. Derivative with respect to any variable of a constant will always be 0. At this point, all you got to do is isolate dy dx. That's it. So move everything else over here. By subtraction, so this will be negative, right? Cross the equals, just swap the signs. Divide by 3y squared. And you're good, at least for this one. So divide both sides by 3y squared. And that's it. There is dy dx. Any questions on 17? (19 and 20 are word problems, and we did a sphere and a circle type already. So I'll leave those to you. (21 and 22 are just formulas. Okay, so y equal to cosine inverse of 5x squared plus 4. So you need the inverse cosine or arc cosine formulas. We'll look them up real quick. Inverse trig functions, trig derivatives. I know this one has a negative somewhere. Double check. Yeah, so this will be the derivative will equal to negative 1 over the square root of 1 minus whatever is inside the argument. Goes right there. But then you got to do times the derivative of that inside. So this inverse trig derivative has a chain rule. This would end up being negative 10x over square root of minus 5x squared minus 4 plus 1, that'll be minus 3. simplified as possible, we'll have this. So 22 and 23 is the same thing. It's just, here, let me show you. It's the same thing, you just use a different formula. One for sine inverse, one for tan inverse. Just remember that if the inside is complex, you'll just put that wherever they have their x, but then you multiply by the derivative of the inside. I think in the notes I gave you the formulas that incorporate the chain part, even when you don't need it, they'll still be in there, so you don't have to worry about it. 24 is the Newton's method, which we just did last time. It was just a formula. So you're going to do this one. Here it gives you x0, so you would do it one time and then two times. And you just write down the two values. That's okay. We'll stop here. You guys have any questions on how to do these? Does it seem doable? The exam should be pretty similar. I didn't do 20 because we did this pretty much almost the same one. In the notes, this is also similar. Anyway. Does this make sense to you? Let's go. Yeah, I mean, the first chapter is just very theoretical. It's very different. This chapter is just, straight up problem solving, which is what most of you are used to in math. So I feel like if you practice, most people will do better here. Just it all depends on your algebra skills and how much you practice. Okay. All right, guys. Well, I'll see you on Tuesday. If you have any questions, let me know. I'll stick around for a bit. If not, I'll see you Tuesday. I haven't put a due date on it, but let's see. Like this week, you should be finishing the review, and 3.7, 3.8 is this week. Technically. Then next week would be when the exam 2 is due. I haven't put a due date on it, but sometime next week would be great. I'll let you know on Tuesday. So I would say it would close 2 weeks from now at the latest. Have a great day. Thanks. You too, man.